In our last example, we explored the classic motto that correlation does not mean causation. And it's true, it doesn't. It's a very important thing to know. But the reason it doesn't is because, well, one of the many reasons is because of lurking variables. So let's look at that just a little bit more. Lurking variables are variables that will affect both your x and your y. So you'll have a variable that affected what was going on. So you were looking at the x and the y, and then you didn't even notice, but in the background, something else was happening. So for example, in our case, we were looking at free reduced lunch and passing math, but there could be other things like the income level of your school district or the poverty level of your school district, etc., that are affecting both of those values. All right, so I have this lovely comic from Jason Love, who gave me permission to use it, and I loved it when at this moment I saw it, because it says that statistics show that crime rates rise with the sales of ice cream, which is true. So now do your part and move along. So they boarded up the ice cream store, so that'll get rid of all crime, which I don't think that's true, because personally I will get very upset and want to get my ice cream. It'll make me very angry. So what's happening here? Well, we have an x variable, which is ice cream, and we have a y variable, which is crime. And the cop is thinking that correlation means causation. That if I see that ice cream sales and crime rates rise together, which they do, by the way, this is totally true, they have a positive relationship. So when one goes up, the other goes up. When one goes down, the other goes down. But it's not the ice cream that's causing that crime. Right? And that's the mistake that the police officer is making. So they're saying, I'm just going to board up the ice cream and everything will be better. But that's a big no-no, right? This police officer is mistaking something else that's going on. There's a third variable that's affecting things, which is the lurking variable. And the lurking variable would be season, right? So weather or the season. See, the thing is that crime is much more likely in the summertime. Because if you're going to steal a big screen TV, you don't want to do it in the snow because one, you leave tire tracks, two, you could fall and hurt yourself carrying the TV, and three, it's cold outside. Who wants to rob anything in the cold, right? So the lurking variable is season, right? And the officer is missing that, right, by boarding it up. So it's one variable, season. It affects the ice cream sales, right? Because in summertime, ice cream sales go up. But in summertime, crime rate goes up. I'm sorry to say that one of the classic examples of this is actually Chicago. In Chicago, every year on July 4th weekend for the last several years, there has been huge crime waves with a lot of shootings and murders. And one of the reasons for that is people are more likely to be out and about, getting into arguments, fighting with each other when it's warm, right? They're sticky, they're grumpy, they're out seeing each other, and people just lose their tempers and fights happen, amongst other things. So summertime tends to be a higher crime time. So when you do these problems and you say correlation is not causation, again, that is not enough. So you say that part, correlation is not causation, which I labeled green over here. So correlation is not causation. Then you say because of lurking variables, right? So there's another point right there. So know that it's lurking variables. But then you have to be able to come up with some, right? Come up with at least one good one that affects both the X and the Y, right? And I'll just put example. So you could use season, you could use, here, I'll just put season. That way you can see for this example. Season or poverty level or, whatever. You're picking something. Okay, so a researcher wants to know whether cola consumption is associated with lower bone mineral density in women. She collects data from a random sample of women. She asked the women how many colas they drink per week and then measured their bone density. All right, now again, reading computer output is kind of a big deal for us. We should be able to kind of read and analyze what we're looking at. So I've drawn the scatter diagram. You can see the number of colas per week is our x. It's on the x-axis. So that's our explanatory variable. The bone mineral density is our y. So that's the response variable. All right, now the correlation coefficient is right there in the data output. Do you see where it says R equals negative 0.8056? That's our correlation coefficient. There we go. Simple as that. Now, what kind of relationship is that? Well, that's negative for starters, and it's a strong one. It's really close to the moderate zone, but it is strong. Let me scroll back and show you. So negative 0.8056. Let me go show you the graph. Here we are back several pages. So negative 0.8056 is right here. It's just a little bit bigger in magnitude than negative 0.8. So you're over here just a little bit to the left of the negative 0.8 dot. So that would be a strong negative relationship. All right, now a woman from the study tells the researcher that lately she's been drinking more colas per week. Okay, so you see what I'm doing there? I'm increasing my X value. So she's been drinking more colas, so she's moving to the right on the graph. What would the researcher expect her bone density to be? Now, I'm not asking for a specific number. Really what I'm asking here is for you to kind of describe the trend. So if you increase your X, then your bone mineral density tends to go down. That's because it's a negative relationship. So therefore, I would expect her bone density to decrease. There we go. So because of that negative relationship, I would expect her bone density to be lower. All right, and you can see the downward trend when you look at the graph. I mean, that is a negative relationship. Does the study prove that drinking colas causes, that's a warning sign, lower bone density? And the answer is no, it does not. And the reason being because this is an observational study. The researcher didn't randomly assign colas to people. She was observing what they were already drinking. Okay, so I typed up what I just said. The strong negative correlation does not mean causation. And I'm going a little bit farther here. This is because this was an observational study, and therefore there may be lurking variables, such as the fitness level of the participants. See, everybody chose to drink colas on their own, and that might affect what's going on, because if they're choosing to drink colas, maybe they have a lower health and fitness level than somebody who would not choose to drink colas, right? And this brings us to a very important note that I'm actually going to add to the box up above, which is to have an experiment. The researcher would have to have randomly assigned cola drinking to people. And that means that you can't do that, right? Well, I mean, I guess you could if people are willing to do it for a short-term study. But even people that are willing to drink colas might be different than people that are never willing to drink colas no matter what. And this brings me to this point right here, which is the one way to avoid lurking variables, kind of the only way, is to have a very carefully designed experiment with randomization rather than an observational study. Observational studies, it's really basically impossible to avoid lurking variables because you are just observing what already occurs. You're not randomly assigning people into groups. To make it so this bone density was useful, the researcher really should randomly assign people to drink cola and not drink cola. Because they didn't do that, there's going to be lurking variables. So, observational studies are going to have lurking variables, and the question is to find them. Right? You'll notice that sometimes it's unethical. This is not necessarily one of those cases, but there are a lot of times where it's unethical to do an experiment. And so you're just going to have to live with the fact that there are lurking variables, right? Because to have an experiment means you have to have a good experiment. You have to have randomization. You have to have people be randomly assigned to groups, to the treatment group, to the control group, etc. And if they're not randomly assigned, then you're going to have lurking variable problems. And the question, and those lurking variable problems mean that correlation is not causation. And what's more, then you're going to have to ask yourself, hey, what are some lurking variables that would affect what's going on here?